Well, we might as well go ahead and begin. So, thank you for joining us today. If you really like what you see, like, subscribe, hit the bell notification so you can be informed when our newest videos get dropped on YouTube. We really appreciate it. So the last video we left off PCB layout. Pretty much again, we're still just kind of finding a location for everything before we start doing any actual plumbing work to where we're actually putting traces on the board. So right now we're going to go ahead and start working on the USB UART bridge circuit down here. Let's go into the schematic and find the rest of the parts that support the bridge chip. So we have C20 and C21. Okay, so let's uncheck that. C21, C20. Then R22. R22. Right. Over here, R18, 19. R18 and 19. R18, 19. C18 and 19. All right. And 19. Again, we're looking for the components that directly affect the USB UART interface. Then over here, we have the USB connector, TP22 and 23. With D5 and D6, they're the TVS diodes. To protect the inputs. Oh. So we should have all these guys. Let's kind of pull them up around the bridge chip. Okay. So now we have quite a few components. We'll probably populate on the bottom side for a lot of this. So let's see what we got. Getting USB. So see how this looks here. Okay, we'll leave the bridge chip, the actual bridge chip up here. The USB positive, negative. We're going to try to kind of line up to get some better straight traces. We're going to go and pull that back. So let's go to 4 and 15. BP. Yeah, we're having a little crossover situation here and there, but that's 9. Yeah, so we're going to pop that up a little bit, probably 15.5. All right, we can clean that up, deal with that. All right, TVS diodes. We're going to have some vias in the USB bus. It's going to be unavoidable. So let's put these guys on the bottom. Our TVS diodes. We're not technically moving data through them, so this guy's going on the bottom. And then all these supporting capacitors and resistor. So 21 and 20 are actually for the power supply going into the one. So 3.3 volts. Nope, I'm trying to figure out where you're going to sit. 3.3 volts. Okay. That's kind of fine. That's reset, so that's a kind of different circuit. That we can actually throw on the bottom. Not directly under, because we're going to have vias in here to tie into the ground plane and things like that. So I'm not terribly worried about that right now. All right. We'll figure out that guy up go on the bottom. These will stay on top to be close to the actual supply pins. All right. That's off the V bus. We're going to throw down on the bottom. And 19 and 18. They are the voltage dividers. We'll just go and throw those on the back side, the bottom of the board. This will go along. Go along with okay, right there. All right. It's C19. Let's verify. Okay. C18 and 19 are part of the V bus line. I must have missed that one. Yeah, here's 18, so and 18 over there too. All right. See 18. Let's double check, make sure I got that one. Yep, 18 and 18. Now let's try to make sense of all this. And we also have the two test points that we want to kind of drop into. The through hole, so we can just throw traces actually on a even an inner layer if we have to. We'll worry about them here in a little bit. So these guys support this. Let's go ahead and choose our text. What's that? We'll just kind of put that there for now. All right. 109. Let's go to 21. Well, those numbers look like they work for me, because then we'll tie into the 3v3 lines here. Okay. So this ground. You could share that ground plane right there. All right. Let's kind of figure this out here. Okay, capacitor, so we have that guy. The thing is, we don't have anything connected to these pins, so we can don't have to worry about really dropping vias too close to them. So what we can do then is push you a little further over this way. Maybe hold on here. $20. Okay. Yeah, we're definitely gonna have to do some serious kung fu on this stuff. Here's the other capacitor. V-bus. V-bus, okay. V-bus. 20. All right. So. All right, this is where things might get a little crazy, but that's okay. We can handle it. Let's see. Basically, switch down to the bottom layer here, make it a little easier. All right. So then we have. Okay, this is the reset. It's not all the way. Because we have this guy that comes in off of the V bus itself. Technically, it'll be more like over here. Hmm. Uh, 20. 20. Okay. It definitely clears. What we're going to do is we're going to not that far. Okay, too close. Go. We are going to do this. Not a big fan of doing it this way, but it works. To help basically stack the designators. There we go. Okay. So then we have this. You can always just take a tracer on that way. It's just like a pull-up resistor, so not terribly worried. E. All right, there. Then we could just 109. All right, that should be sufficient there. Okay. There we go. Okay. Now we're going to have to place our TVS diodes. This is for V-bus. So because of that, and the other one's unused, we could just kind of sneak that guy underneath the connector. The guy can sneak up underneath the connector. You can kind of sneak this guy up in here for now. May have to rearrange based off of push you up to 11. And kind of tag along. So that's 7.5. No, too far. Let's go. Perfect. All right. All right. Okay. That's looking like it might work okay. We may have to make some adjustments when we actually go to do the routing, but we'll find out. We'll leave well enough alone as it is, just in case. All right. So the next most difficult part, honestly, is going to be laying out the stepper motor driver. So we got all the components set up here. All right. So we've got that where we want it. So I think we do. Nope. All right. Okay. Okay, those are your sense resistors. That can honestly go on the bottom. All right. We can probably snug that a little closer. A little closer. We want to make sure we have room to throw in parts. And we're not really hurting for real estate right now. Because the only parts that we need to slam back on, we need to get on here are for the ESP32. Right there. And that should actually be enough. One of these parts I think will be for the, I don't know if I set up the fan tach right. We might have to fix that. It'll be no problem. I'm going to need a pull-up resistor. I think it's a 1K. 1K or 10K pull-up resistor. I think it's a 1K pull-up resistor. Off the fan tach. Oh, did I make that mistake? Let's go back here. All right. Yes, I did. And that is going to be, yep, I made that mistake. So it's going to be a resistor. I think it's just a 1K. And we're going to pull off of Can always change it if need be, but I think a 1K is what it is. So we need that. That was a mistake I had made. Mm. 65, 27. So technically, that'll go up underneath that guy. All right. So we're concentrating on the stepper. I got distracted there because I had made a mistake. So let's check our capacitor here. Where's our 24 volt input? It's right here. It's actually two major 24 volt inputs. So it's gonna make life a little bit difficult, but we can manage. So I might do something not perfect. That kind of works. That's close. Because we need to get this guy and this guy, but we also have our motor outputs. We'll figure that out. We'll cross that bridge when we get to it. Okay, so there's our current sense. Here is this little guy. I could even throw that on the bottom. Don't know yet, though. Okay, sense A. Sense B. Okay. Okay. I have a feeling I'm going to be using the internal signal layers. Throwing some power planes in there. Polygon bores. Not a problem. Not a big issue. Okay. Okay, we'll fix all of that. Okay. Honestly, these control resistors, since we don't want to crowd that guy out too much, we can actually put them closer to the ESP32. But, yeah, right here. We can just kind of put them by the ESP32. That will make our lives a little bit easier. We're 25. Let's check that guy out here. 25. Here's our 25. Oh, right here. Okay. All right. Let's see here. C25 and R25 kind of go together. C25, R25. Okay. All right. Guess off the 24 volt. Okay. I'll go here. What I might be able to do some strange kung fu. So 24 volts will more likely be up here. Get you out of my way, get you out of my way. Okay. And then you have these, which are essentially noise filter caps. Which I want to kind of 23 and 24. Let's just double check. Yeah, 23 and 24. Basically, just help pull noise out of the line. All right. Clean all that up as we go, but we got a general rough shot estimate of how things are going to go. Oh, wait a minute. 28, 29, and C27. Or 28, 29, C27. Okay. All right. Actually, I can throw these guys on the back side as well. Right. And well, I don't know. I mean, we got plenty of real estate. Not really hurting for room. Let's go put this back on the front side. Just minimize our vias. Okay, so that'll be grounded. So hold on here. So we're gonna 23 out. Okay. We'll put you here. We'll clean you up here a little bit. Okay. Mm. Mm. Figure that out here. Which is fine. And go there. All right. Okay, we'll clean that up as necessary, but I think the general gist is when we start routing the actual traces, we'll clean that up a little bit. So that should do it for that fella. No, this is programming for the ESP32. Okay, I think there's one, switch two. Those are our boot modes and reset. R20 and R21, I think. Okay, so R21, R20 and R21, they go for the, they go with the transistor. That's what sets up the auto program mode. These guys are just on there. Those guys go there. Okay. This guy will go with this guy. All right. All right. All right. All right. So we can probably these are just resistors that help control the logic level. We can probably kind of just throw them in anywhere we have room. ESP32. Let's go on centralize you. Let's go ahead and push you up one more, up another millimeter from the edge here. This guy will throw you on the bottom with the logic control resistors. Figure you out where to go, but you will be underneath the ESP32. All right. So those will be the boot mode and reset. So think about where we want those. So what we could do, push the ESP up a little bit further. These guys, let's just pretend those guys are right there. Put these on the edge of the board. Far enough away from each other that they're not going to get in each other's way. Okay, so we have V bus. Oh crap, I forgot about that. Oh, that's fine. Five. Okay. All right. Fine. I can kind of just do some fancy routing and tie it into there. It's just a test point for voltage. I'll see this ground. Kind of go in here because I can kind of tag these signals anywhere in here, and that's fine. We'll just have this ground. I mean, we also have that ground point right there, so let's just do it. Let's just 7.5. Okay, so let's push you over there. Beautiful. Throw you back in here. Boom, there we go. 2, switch 1. We'll kind of really define their positions later. We can throw these guys in. Honestly, these guys can kind of chilling around this, but we'll figure that out later. We're so close. We've got most of the things. I just kind of figured out how we want to do them. But right now, I don't think it's extremely important to set them all out. Because now we know everything's going to fit. We can make everything fit. And that's not going to be a problem. Now it's just kind of just how we want it to look. Okay, so this guy we will throw on the bottom. That goes with the ESP enable. That's part of that circuit. Same with this guy. That would go with this circuit. Much easier. We'll just limit the chip. That's the boot mode. We can actually put that by that switch. And something else I kind of want to throw in here that I've seen done on other circuits. So let's go to here. And drop in another TVS diode. And you'll see why here in a minute. It's a little sloppy, but put some a TVS diode to protect those two switches to help cover any incidental. It's a small piece of insurance to help protect any surges from coming in from human contact to those two switches. Now we're going to tools, update. We're going to pull in that TVS diode, which will drop it there. And all right, this guy could honestly just sit him right here in between the two switches. It will not hurt anything. All right. Oh, one of the things I do want to mention too is I went through the library and actually created a step file library. So now all of the, pardon me, I'm sorry, I'm still fighting that cold or whatever. So I actually created a library for the step files and went in and updated all the footprints to properly have the information, to have the proper step files. If you download the project from GitHub and change your directory structure for everything you may have to readjust all of them, but they'll all be there. You just have to point them to the new directory and then just follow suit for future work. So now all the 3D step files will be present on the PCB. We'll go through and, like I said, we'll clean this up. You know, honestly, we can, that guy can honestly stay on top right now. We'll see how it goes. We can always throw on the bottom and throw some vias to connect it. These guys will figure out how to throw them in once we get all this figured out. Not a big idea. Big deal. Not big idea. Well, we definitely have the room. We know we have the room now. Now, one thing, I'm just going to preliminary drop this right here, the logo file right here. It may not stay there. And then because there's going to be a bunch of other things we're going to do. We may have to move that around. We will find out. But we will cross those bridges when we get to them. Something I do want to do, and it's a habit. So we're going to throw a string of text on right now the top copper layer. And we're going to name it PCB dash 01. Basically the part number for the circuit board. So now that'll be in the copper layer. We can just throw it on the bottom side. We're going to throw it on bottom copper. Mirrored. There we go. So now we have basically the part and version number for this PCB kind of permanently in the copper layer on the bottom side. That way it can't be rubbed off or easily removed. You'll notice it. Plus we have a hard version revision right here for tracking. This is a common practice. Something we try to do in all our boards. So let's go give it some clean XY coordinates. We may have to move it depending on if we have to run any vias near, any traces near it, but where it sits, it should be fine. So now that we've got our setup pretty good, we'll probably have to make some changes. Sorry. Like I said, this cold is really messing with me, draining me, making me tired. We'll have to probably make some changes, nudge some parts around, but that's fine. We have the real estate for it. Everything will fit. We can even get these test points in here once we know better of our layout for the rest of these parts, which is good. This is perfect. So let's go and start plumbing things together. All right, so we're going to look at some of our big power planes. So route single track. All right, I've never done this before, so let's see what this guy does. All right, that's the main power plane. So we are going to, okay, so let's uncheck footprints and text. Let's check tracks for now. We're at 0.2 millimeter. All right. All right, so I want our signal lines to be 0.254 or 0.127. So there should be rules. So let's go see if we can find the design rules. Here is it port setup, port stack up, pace, constraints. Minimum, okay. The minimum track width, okay. Okay, 0.127 is the absolute minimum. All right, clearance. All right. I think it's 0.254. Minimum copper. There should be okay, predefined 0.127, 0.254. Okay. Let's see what that does. So let's go route. See what that does. Weird. Okay. But we're not going to use a predefined size because that is going to be a heavier current carrying line. So one of the things, you can use a trace width calculator converter. So DigiKey has one. I can throw that into the resources for the video, the file the markdown file I've been keeping with all the different links and stuff. I'll throw that link in there. It's really handy to know. So we know our copper is 2 ounce. We're going to be doing 2 ounce copper. Current, let's say 2 amps. ambient temperature, we're going to assume room temperature, roughly 22 degrees Celsius. T-rise, I don't know if we need to know that. Let's just go 5. Okay. So let's see here. Temporize. Calculate the rest. So let's say the maximum temperature, we expect it to rise. So we got 2 amps, 2 ounce copper per square foot. Okay. Ambient temperature is 21 degrees. Let's say 22. So what it calculates is, so here's an internal trace. So that is if you're in between layers, if you're actually inside the board, or if you're external, top or bottom. So 0.390 is the minimum they recommend for a trace with 2 ounce copper at 22 degrees Celsius ambient temperature, where the temperature is expected to rise by 10 degrees Celsius. So basically 33 degrees Celsius. And then you're carrying 2 amps of current. So that's actually not that bad. So we can actually, we're actually going to punch that up a little bit to 0.508. So now that current, we should be able to handle the 2 amps of current with plenty of wiggle room. So we're going to go ahead and just kind of route and oh, all right. Yes, I can't. Could create that a preset, but all right. Now, realistically, these power supplies shouldn't need a big trace like that, but we're already doing it. Let's just go ahead and do it for consistency's sake. Because the main thing that we got to drive that power is over here to the stepper motor. But we're not working on that. So one of the things I want to do real quick before I get too far ahead of myself is tie. So in the last video, I think it's in your board setup, we did. So we got the power plane set up here. But I want to figure out how to actually tell it. Net classes. I want to be able to custom rules. I don't have to figure out all this. We'll do the vias here in a minute when I get started on them. I'm going to be able to tell what net that these power planes are going to tie to. So I'm going to just kind of pull this guy off screen. That way I can look real quick. I want to define a power plane net. So I have to actually, all right, that's kind of goofy. Guess it's fine. So we're going to, we have to go to this copper plane. We're on the inside. I guess we got to do a region. Okay, so the first one we will be anyway, we have two different nets, 3.3 and 3v3. Let's go and make sure we don't have any weird freaking nuts going on here. 3v3, 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 3v3. Make sure there's no weird nets. Ah. I accidentally did. All right. 3v3. Yep. That would have been a disaster. Wait here. Why do I have separate nets here? That was my mistake. I didn't catch it. And it's going to be the same on here. Okay. I can't believe I did that. Can I just change these to 3v3? Yes, I can. What are they? Plus 3v3. My mistake. Tie-ups. Three v three. It's kind of funny. 3v3. So we get that right. Now we're gonna have to go back over here. References, tools, update, close. All right. Now let's see what happens. 3v3. Okay, we're drawing that. All right, cool. So the hash marks right there indicate the pullback from the board edge of, I think, 0.5 millimeter. So that's the 3v3 power plane. And then, so top signal, power plane, signal, power plane. And that's going to be ground. So let's draw that, and that's going to be your ground plane. Ground. All right. So region, I guess, looks to be the same thing as a polygon. I can always fix that. Doesn't really technically matter. But I think I could be able to edit that point. This is not going to hurt anything. All items. Oh, there we go. All right. Okay. So now we have a ground plane. Now, does it show it actually tied in? No. Now, there's typically other rules you can define for planes and stuff. Other rules, constraints. Yeah, we'll have to see how it looks. For setup, constraints. Anything for rules. Okay. All right, so that should take care of that. So now our 3.3 volt and our ground plane are now defined. Let's go back up to here. So now we need to route the plus 24 volt bus basically over here to the first capacitor. Oh, nice. It already selected my size. Okay, give ourselves plenty of berthing space. And it should already be 508. All right, cool. So now we have our 24 volt routed across the top of the board. That's fine. Should be plenty of room to breathe. So now what we're going to do is get some additional routing done. All right. All right. So there's that. That should be the main power coming in. Because of the nature of the switching power supplies, how they operate, your input current is not anywhere near what you can output due to how the switching mode operates. So this should be more than sufficient based off the calculation and the fact it's going to be a 2-ounce copper pour. So now technically the ground plane should already be here. It should electrically be connected to all these grounds should. I think they're just tying to these guys. So let's start getting some of these guys wired in. 3v3. So what we're going to do. Alright. Alright, so we're going to need ground. But I don't want to make big pour, so we're going to do kind of, you know, let's go ahead and define that real quick before I get too far ahead of myself. Here we go. So let's get in here and predefined sizes. We're going to do a via diameter with a hole. 0.559. That's going to be the big guy. Or is it? No, that's the signal via 0.254. All right, and then we're going to put in the other size, 0.813, with a hole of 0.457. Okay, save. Because what we're going to do then is we're going to throw in a ground pour, a ground plane. That's going to be on ground. Nope. Oh, there we go. All right. So now we're going to, can we just drop a via? Let's go and grab via. It's a via. Can we do a preset? Huh. Boom. All right. So, okay. It'll work. Okay, zones, I guess, will be the polygon. Yep, all right, there we go. So now we got this big old via. Does it say what net it's part of? Is it complaining about the net? Automatically update via nets. So all right. Okay, so let's trim down the nope. Okay. We can trim down the size of the pour. Doesn't have to be this big. All right. Outline display. Fully hatched. Okay, that's what that is. Hatched. Okay. Let's save something. Let's see if we can see. So we should be seeing a copper pour. So we have the vias right here, the big power vias. But there's no copper pour there. So fill. Why isn't it filling? It should be tied to ground. Pad connects, okay. Then we'll release. Do we have to fill? Manager. Update display zones. Yeah, so we should see like basically a copper pour on that layer. Okay, let's go back to my search, KiCad. Delay. Region. Fill zone. Why? Zone's not filling. The pour outline is not closed. Oh. You know, let's try putting another one on there. Oh, it should be closed. Yeah. Why aren't you filling the region? Tools. No. Yeah, this is the fun of trying to fill it in, of figuring out how to do this. Oh, fill all zones. Aha, there we go. Okay, so that means these vias are not set. Ground. Okay. Oh no! Don't do that to me. Ground. Oh, okay. Now, if I go to Tools, View, Fill all zones. There we go. Okay. All right. So why isn't it filling over the pads? So we got to figure that out. All right. Let's see if we get rid of the thermal release. Let's just get rid of the solid. Okay. All right. So now if we go here, okay, now we see the copper pour. Okay. All right. So the reason I'm doing this, okay, now we've got all the connections in and outside the board. Okay. So we have that. So what I might do, okay. Ugh. All right. Let's see here. Let's also get rid of, let's go to, let's see, that is 3.3. So let's also change that to no release. Let's see what that does here. Edit, fill all zones. The ground. Solid. Okay. Why is that not? Okay. That should be tying to those vias. You. Okay. So that should actually be connected there. So, yeah. Oh, wait a minute. Okay. It's connected. My bad. All right. Okay. Okay, it's connected. It looks like it's connected. All right. So because that's going to be annoying, we're going to unfill all the zones. And that, yeah, going by that way, it's going to be annoying to try to stare all this at the same time. So what I've done here is create some very solid connections for the ground. We'll go through and do that for other parts, but for now, this gives us nice solid connections to the ground plane with a nice big polygon pour, or region pour as it's called in here. Region. We can make that smaller. There we go. That way the ground connection is nice solid vias to the ground plane. And when we see power planes like that, or especially grounds and stuff, we will follow that same principle to connect them all. Moving forward. So for now, I think we'll leave things alone. It'd be a good spot to leave off. We started our routing finally. So next video, we should be able to jump more into getting a lot more of the routing done, nudging more of the parts, getting more things defined and figure it out. Hopefully within the next few videos, we'll get all the routing done, all the final parts placement done, and be able to maybe hopefully start ordering the parts. We'll see how that goes. Definitely do a design review. So I thank everybody for watching, checking in. You have a good evening.